So here we have a problem that we want to solve for x, and the equation that we want to solve for x has a variable in the exponent. So this is considered an exponential equation, and I'm going to show two different strategies on how to solve this equation for x. In this case, because we have 2 to the power of 2x plus 1 is equal to 32, because 32 can be written as 2 to the power of 5, we can rewrite the equation as 2 to the power of 2x plus 1 is equal to 2 to the power of 5. So from here, because my bases can be written as the same number, I can then set my exponents equal to each other and just drop the bases. From here, I just need to solve this linear equation. I can subtract 1 on both sides to make 2x is equal to 4. Divide both sides by 2 to finish solving for x. X is equal to 2. So that is one strategy, but that strategy is you can only use when you can write your number, that's the other side of the base with the exponent, as the same base. To do a more general solution, let me rewrite the problem. A more general solution when, or for example, if you want this, if you have a number on this side that is not necessarily able to be written as the same base, we can use the form that if we have b to the power of x is equal to y, we can rewrite in the log form as log base b of y is equal to x. So the way I remember that is the base of the exponent becomes the base of the log, so you're just dropping that base to the base of the log. Then you're kicking the exponent out and solving for the exponent. So that's where the log form can be most helpful, is if you are trying to solve for a variable that's in an exponent. Okay, so using that form and converting from exponential form like this to log form, we can rewrite this as log base 2 of 32 is equal to 2x plus 1. So I dropped my base. The side that was just the number goes inside the log, and the exponent gets kicked to the other side. Okay, from here to finish solving, we can use the change of base formula because most people don't have a calculator that can evaluate a log base 2. It's mostly either just log base 10 or log base e, which is natural log. So we can use the change of base formula, which says if you have log base b of y, you can rewrite that as log of any new base, log base a for example, of y over log of that same new base a of b. So you're dropping the base down to the bottom. And where this is helpful is if we use our new base as being like log base 10, for example, because we have that in our calculator. So we can rewrite this as log base 10, which is typically not written, of 32 over log, again, base 10 of 2. And just bring down the right-hand side. From here, if we put log of 32 divided by 2 in our calculator, that simplifies to 5. So 5 is equal to 2x plus 1. We are back at this step of our previous step-by-step solution, so we can subtract 1 on both sides, just the same as we did before, divide both sides by 2, and we get, again, that 2 is equal to x. So we get the same answer for both of these. This is the more general form of solving because you can do this with any exponential equation as long as it's a number to an expression of x is equal to another number. But this one is less steps, so it's easier to do if you have a number that can be written with the same base as the other side. Okay, well, I hope this step-by-step solution was helpful for you. If it was, please like the video and subscribe to my channel if you'd like to see any more similar videos. Also, feel free to leave any problems that you would like to see a similar video like this for, a walkthrough. Leave those either down in the comments or send me an email. My contact information is down in the description below, and as far as I have time, I will do my best to get you whichever problems that you would like to see a video that are in my wheelhouse of subjects, which is algebra, trigonometry, geometry, calculus, chemistry, or physics. So feel free to ask for a video, or ask for a problem to be shown a video over if you would like to. Well, happy studies, and thanks for watching.